continue with our videos in the mathematics in the real world. Here we're going to talk more about Pascal's triangle, and we're going to now see it in a different new perspective, where we're going to apply it in the field of combinatorics and probability theory. Okay, so it is also used here in these branches of mathematics in determining a probability of an event. Okay, so specifically, we use this concept in the binomial distribution. So this is one concept under the main topic of random variables. So say we have this problem. A newlywed's dream family is to have 5 children. So that is with 3 girls and 2 boys. Since you are considering 5 children, we will consider the row 5 of the Pascal's triangle. So we're going to take care like this. So we're going to look at the row 5. So row 5 is 1, 1, 1, 1, 2, 1. This is row 2. 1, 3, 3, 1, 1, 4, 6, 4, 1. And row 5 will look like 1, 5, 10, 10, 5, 1. So remember this, 1, 5, 10, 10, 5, 1. So how do we answer things like this? So we're going to take put it like 1, 5, 10, 10, 5, 1. Remember that the newlywed couple wants to have 3 girls and 2 boys. So they want 3 girls and 2 boys. So take note that we can only focus on one gender or one sex. Let's say we'll focus on the girls. So we'll have this as the number of girls here, and we can have 0 girls actually, meaning all the children are all boys. We can have 1 girl, 2 girls, 3 girls, 4 girls, or 5 girls. Meaning these numbers here in the blue pen is telling us the number of ways we can have 0 girls, we can have 1 girl, we can have 2 girls, 3 girls, 4 girls, and the rest. So how do we mean by this? So for example, if you may ask a question, how can you come up with exactly 0 girls? So there's only one way. These are the number of ways. It's the only way is that all your children are gonna be boys. Boy, 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 boy. So that's gonna be the only way for you to have 0 girls. Okay, now how can you get 1 girl? So there are 5 ways. It could be that the girl is the eldest, so you can write it like this. It could be the girl is the second child, so we can write it as boy, girl, boy, boy, boy. You can as well write it like the girl is in the exactly in the middle child, boy, boy, girl, boy, boy. You may also write it as the girl will be on the fourth child, boy, 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 girl, boy. And if it can be that the girl is the youngest, boy, 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 girl. So meaning there are 5 ways for you to have um, a, an arrangement of children of sexes to be exactly 1 girl. For how can it be in such a way that when you want 2 girls, there are 10 ways. So I'm going to illustrate this. This is similar to number 3, no? That it will give you 10 possible ways as well. Also, so what we have is, for example, 2 girls, right? It could be that 2 girls is or are the eldest, so girl, girl, boy, boy. It could be like girl, boy, boy. The eldest and the middle child is a girl. It could be that the eldest and the fourth child is a girl. It could also be that the eldest and the youngest are girls. Now, also, it could be that a boy is the youngest, and then the next 2 children are girls, and then boys. Then it could be that the boy is the um, eldest, and then girl, and then boy, and then girl for the fourth child, and then girl, and then boy. We could also have boy, girl, 2 boys, and then the youngest will be another girl. We're done there. Next is what if the first two sexes are boys? So we can have 2 girls right here and a boy. And we can also have boy, 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 girl. And lastly, we can have 3 boys and 2 girls. So all of these will give us 10 possible choices for two girls. Of course, if we have two girls, we'll have five boys automatically. So I'll leave the others for you to see. Actually, they are a mirror image of 1, 5, 10. So this will be 10, 5, 1. You can just try to restructure this into boy, boy, girl, 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 and then you can see the how the structure is gonna happen. So the thing is, what we want is this couple wants three girls. So we're just asking the probability. We're like asking the probability of what the probability of having three girls, exactly three girls. So of course, if you have three girls, it's going to be given that it will be two boys. Remember that the probability of any event E is going to be equal to the total number of sample points in E divided by the total number or total um, cardinality of the sample space. So the sample space is just, you just need to add all of these. 1 plus 5 plus 10 plus 10 plus 5 plus 1. That's 16 plus 16. That's going to give you 32. This is your N of S, 32. How about your 32, right? How about your N of E? How many ways can you get three girls? So um, you can see that pretty much clearly that there are 10 ways for you to get two girls. Or rather, that's quite wrong. Sorry. There's still 10 ways, but the encircled one is wrong. So there are 10 ways for you to get three girls. So meaning what we want is 10 over 32. This can be simplified as 5 over 16. And I think that's the simplest form. And that's our answer for this problem. You may want to change this in decimal form. You can just really answer that. Okay. And then that's one example of the application of binomial theorem or binomial distribution, sorry, making use of the Pascal's triangle. Okay, so if you really want it to be in decimal format, we can proceed here, and the decimal format is going to be this. That's 31.25%. So that's it for this video. It's quite a short one. I'm going to give you another example maybe in the next video. So stay tuned. Always be there. Don't forget to hit like and also subscribe. So thank you very much for watching.